Okay, class, good evening. Leo tulikuwa tunaangalia moments na tukadefine the principle of moments na tukasema the condition for equilibrium. So we had this question that the figure below shows 1 meter uniform plank of weight 20 grams at equilibrium. And the question was determine the forces. The question was to determine the force at point A and point B. Now we look keenly, point A and point B, that are the support of this body. So tumesema kwamba for moments tumesema the sum of anticlockwise moments is equal to sum of clockwise moments. Na pia tukasema for equilibrium sum of upward forces is equal to sum of what? Downward forces. And so we know that at every point of contact, for every action, there is an equal but opposite reaction. So since this body is at equilibrium, then it means we have upward forces, and these upward forces can be at the point of contact with what? The pivot, that is point A and point B. So at point A, at the point of contact, I can have the reaction force at that point, niite F1. Here at point of contact with the pivot at point B, na izaita nini? Reaction force F2. So tumesema this is a meter uniform. So it means the distance from there, it is 0 up and what? 100 centimeters. That is 1 meter. Okay, now, so to determine the forces acting at supports A and B, then it means tunaenda kutumia both principles, the principle of equilibrium and the principle of moments. So first, wacha tuende to determine the principle of equilibrium. For equilibrium, tumesema upward forces, the sum of upward forces is equal to downward forces. So at a sum of upward forces here it is F1 plus F2 is equal to what? The sum of downward forces. Now the sum of downward forces, that is the force. We have the force here, that was 10 Newton. So we have a force at 30 centimeters from the pivot. That's the force. We have the force due to the weight of the plank ambayo tumepatiwa a mass of 20 grams. So we convert this mass 20 grams into weight. Yeah, mass is equal to what? Weight is mass times gravity. So first of all, convert this mass of 20 into kilograms, and then you multiply by 10. For mass is equal to, weight is equal to mg. So the mass converted to kilograms, and then we multiply by 10. And then we have the force, the second force, which is 10. So downward forces, that is an act in the downward direction. So we have 5 Newton plus, if I convert that 20, a mass of 20 into weight, and that is 20 divided by 1000, we get 0.02, then times 10 gravity, then inatupatia 0.2 Newton, then plus 10 Newton. So I can add all the downward forces, which gives me 10 plus 0.2 plus 5. So inanipatia nini? 15.0.2 Newton. So F1 plus F2 is equal to, so that's the first step. The first step, tumetafuta upward and downward forces. The second step, tunachukua nini? Moments. So kwa sababu hatujui at any point either A or B, we can take a moment kwa point yoyote, either uchukue moment at point A or moments at point B. Sawa sawa. So let's take moments at point A. Taking moments at point A. So tuchukua moments at point A, tunajua kwamba sum of anticlockwise moments is equal to clockwise moments. Yeah. So tukiangalia at point A, what are the forces which will bring the anticlockwise moments? Tukiangalia at point A, the force that will bring anticlockwise is F2. Because at point A, that is the turning point, so it means F2 will act in the upward, in the anticlockwise direction with respect to point A. So for that moment, we say moment is the perpendicular distance from the pivot to the force acting. So from here, the pivot at A, which is 10 centimeters away from the origin, and then the distance from now the pivot to the other end where F2 acts is 100 minus 10, so that becomes 90. Now into meter, that becomes, so the anticlockwise moment is 0.9 F1, sorry, F2, because we are taking moments at point A, so that is F2 is equal to, remember to say a moment is distance times force, or force times distance. So clockwise moments, so the clockwise moments will be due to force, 5 Newton force, which is at, from the pivot to the force, the distance is 30 centimeters, that is 0.3 times 5 Newton plus another force, it is the weight. Now the weight acts at the center, and at the center of the meter, because it was a meter, a uniform meter, it is 50 centimeters. So the weight acts at 50 centimeters mark. Now 50 centimeters mark from the pivot A, the distance is from the pivot A to 50, the distance is 40 centimeters. So that becomes 0.4 times what? What was the weight? Tulisema ni 0.2. Yeah. Then plus, now the final force that brings about the anticlockwise moment, the final force, it is this 10 Newton. But the distance tumepewa, it is from point B. Now, what is the distance where the 10 Newton force acts with respect to point A? Sasa kutoka point A to the force 10 Newton. Now, this force 10 Newton tumepewa a point from point B backwards. So tumesema from the starting point to the end point at point B, that is 100 centimeters. Now kutoka 100 centimeters ukirudi back 25 centimeters, that nakupatia it is at 75 centimeters. That is from the origin, from the zero mark. Yeah. Now from the pivot A, which is 10 centimeters away from the zero mark, to 75 centimeters mark where the 10 Newton force acts. So hii distance ni sawasawa na 75 minus 10, inakupatia 0.65 meters times what? The force 10. Okay, so ukifanya kwa calculator those two, 0.3 times 5 plus 0.4 times 0.2 plus 0.65 times what? Times 10. Now remember, nimekuwa nikitumia brackets, so you will be bracketing just the way it is, you punch the way it is. Ukiweka brackets iko inapatia 8.08 Newton meters. Yeah. So tumesema kwamba sum of anticlockwise 0.9 F2 is equal to 8.08 Newton meters. So we can get F2 by dividing 0.9. So F2 becomes, answer divided by 0.9. Unapata 8.97778 Newton. That is F2. Now tumepata F2. Remember, F2 is the point, the force at point B. The force at point B. So tunaweza pata the force at point A. Yes. Tulikuwa na equation nasema kwamba F1 plus F2 is equal to 15.2 sum of upward and downward forces. So we have F2 as, so we can substitute F2 into this equation, we get F1. So F1 is equal to 15.2 minus 8.98. 15.2 minus 8.98. So napata it is 6.22 Newton. So that is the force at A. So that is how it is done. So we continue looking at more questions on principle of moments. This was a next question. So kipata zingine pia you can post, we do it, and then I share with you a video, you look at it. Jioni njema.